A red-bellied piranha can remove flesh with triangular teeth that lock together like shears, put dozens in one patch of dark Amazon water, and anything approaching them seems to have made a terrible mistake. But those shoals are not only hunting formations. Research suggests they can also be shields, built by fish trying not to be eaten. And one predator regularly turns the Amazon's monsters into dinner. It is pink, hunting through nearly blinding mud, and shaped more like a river ghost than a killer. The question is not whether the boto hunts dangerous fish, but how they escape it. The piranha's reputation is built from a real weapon. Its teeth are sharp, interlocking, and positioned to slice rather than simply crush. A bite can open skin, sever fins, or remove a mouthful from a larger animal. Around nests, carcasses, or sudden food sources, piranhas may converge quickly, and that sight has created one of the most durable predator myths in the world. The problem is that the myth erases the fish's own risks. A piranha is not the largest thing in its river. It is not protected by armor, and away from the frenzy of feeding, a single fish is a small, exposed target in a system full of hunters. That is why the shoal matters. A group can make it harder for a predator to isolate one individual. More eyes, more movement, and more possible targets create confusion, while the risk of being the fish singled out by an attacker is spread across the group. Experiments with red-bellied piranhas found that the fish responded differently depending on shoal size, and that risk-related behavior could last longer in smaller groups. The finding does not mean every piranha shoal is a panic response. Shoals also form around food, reproduction, habitat, and movement, but it removes the image of a perfectly confident killing squad. At least some of the time, the teeth are traveling inside a defensive formation. The word deadliest creates another trap. There is no single scientific ranking that makes one Amazon fish the deadliest in every situation. Electric eels can deliver powerful electrical discharges. Large catfish carry spines and enormous mouths. Stingrays can drive venomous barbs into a foot. Piranhas possess cutting teeth and cause documented injuries. Each danger depends on the metric: harm to humans, capacity to injure prey, defensive weaponry, or ecological role. This story therefore cannot prove that the boto dominates an official list of killer fish. It can show something more revealing. Animals that appear dangerous from a human perspective still occupy the prey side of another predator's relationship. Now introduce the animal moving through that formation. The Amazon River dolphin is not pink because it belongs in a children's story. Its color varies with age, sex, water conditions, and skin damage, and older males can become intensely pink or mottled. That surface is only the part visible above the water. Beneath it is a large-bodied predator capable of taking fish from a remarkable range of families and habitats. Diet records have identified dozens of fish species in boto remains, including piranha relatives and armored catfish. The list matters because these are not soft, helpless prey waiting in clear water. Some carry spines, some hide in roots, some accelerate into darkness, some can bite back. The menu also needs restraint. Finding members of the piranha family in boto diet records supports the core reversal, but it does not justify placing every spectacular Amazon fish between the dolphin's teeth. The piara, often called the vampire fish because of its long lower fangs, would create an irresistible image. Yet without a reliable species-level record, making it a featured victim would turn visual temptation into false certainty. The river already provides enough verified contradiction. Piranha relatives, croakers, cichlids, caracins, and armored catfish demonstrate a predator capable of handling prey with very different bodies, defenses, and escape strategies. The first answer seems obvious. The dolphin is simply bigger. A large male can weigh many times more than a piranha, and in a direct collision, the fish has little chance. A body that heavy also brings a powerful tail and enough momentum to stun or overpower prey. That explanation is not wrong. Predators need force, and the boto has it, but it is incomplete the moment the river becomes complicated. The Amazon is not a clean swimming lane. At high water, roots, branches, submerged grass, and flooded trunks fill the space. At low water, channels narrow and currents collide. A bulky hunter that cannot turn, break, or locate prey would only be a large animal blundering through brown water. The boto's body solves part of that problem in a way that makes it look less like an ocean dolphin and more like a specialized river animal. Its flippers are broad and unusually flexible, allowing it to turn at slow speed. Its neck is mobile, so the head can swing independently while the body moves through tight spaces. That matters when prey is not ahead in an open corridor, but beneath a branch, beside a submerged trunk, or trying to reverse direction inside a maze of roots. The same flexibility that looks awkward at the surface becomes useful underwater. The dolphin does not need to outswim every fish. It needs to keep a fish from finding a clean escape route. The dolphin's long rostrum adds reach inside that clutter, but it is not a spear that simply impales fish. It carries rows of teeth designed first to seize. Once the prey is controlled, the broader teeth farther back can help process harder material. That division of labor matters in a river, where one target may be slippery and laterally compressed, while another is protected by plates or spines. A generalist predator cannot rebuild its jaws for every meal. It needs one arrangement that can solve several mechanical problems. The boto's mouth extends the same principle seen in its movement and sonar. Versatility matters more than one record-breaking measurement, but maneuverability only helps after the target has been found. In much of the Amazon, visibility collapses within arm's reach. Silt hangs in the water. Brown currents carry particles past the face. Sunlight may reach the surface while the world below remains a shifting wall. The boto's eyes still function, but vision cannot carry the whole hunt. Instead, it emits rapid, high-frequency clicks and listens to the returning echoes. Those echoes contain information about distance, direction, surface, shape, and movement. A fish does not need to be visible in the human sense to become detectable. It only needs to disturb the acoustic field around the dolphin. That does not turn the boto into a sonar-guided missile. River acoustics are messy. A branch can return an echo. A rock can imitate the edge of a body. A school can become a moving cloud of competing signals. Short-range biosonar is useful precisely because the dolphin can update the picture repeatedly as it moves. It samples the space ahead, changes position, samples again, and narrows the problem. The hunt is less like staring at a hidden fish and more like building a moving map from sound. The closer the dolphin gets, the less room there is for the prey's movements to remain ambiguous. Researchers studying wild Amazon river dolphins have recorded this change during prey approaches. As the dolphin closes in on a target, its clicks become more closely spaced and its acoustic output can increase. Near the final approach, the signals can merge into a rapid capture sequence. That pattern does not reveal the dolphin's private thoughts, and it does not prove that every approach ends in a successful kill. It does show that the sound field changes as the physical problem changes. Far away, the dolphin is searching. Near the fish, it is making fast corrections. Every echo arrives while the prey is moving. The current is shifting, and the river is filling the background with false surfaces. The strangest part is that the acoustic beam itself can become broader near the target, A narrow beam is useful for examining one direction. A broader beam can help keep an evasive fish inside the dolphin's acoustic attention as the distance closes. This is a small detail with a large consequence. The advantage is not just strong sonar. It is control over where uncertainty is allowed to remain. The dolphin can approach a target in water that looks opaque, keep updating its position, and reduce the chance that one sudden turn will make the fish disappear from the map. Piranha teeth are dangerous at contact. The Boto system is designed to decide where contact will happen. Consider the final seconds without inventing a perfect cinematic kill. A fish changes direction near a submerged branch. The dolphin does not need to identify it by color or see the expression of its body. Echoes reveal that a moving surface has shifted. The click interval shortens as the range decreases. The head can turn while the torso follows, broad flippers controlling the bend. If the fish cuts toward open water, it may gain speed. If it cuts deeper into the roots, it may reduce the dolphin's room. Neither route guarantees survival. The chase is a contest between rapidly updated information and rapidly changing escape options. There is another reason the piranha's reputation can mislead. A piranha's bite is most effective when the fish can orient its jaws toward vulnerable flesh. A dolphin attacks from a different physical scale. Its front teeth can seize prey, while teeth farther back are adapted for handling a varied diet that includes fish with harder bodies or protective structures. The point is not that the Boto chews through every armored fish like a machine. The point is that it is not restricted to one fragile prey type. Its mouth is a tool for gripping and processing a changing menu, which gives the dolphin more options when a river channel contains several kinds of fish competing for the same escape space. Yet no individual fish is the whole story. The Amazon changes shape with the flood pulse. During rising water, fish move into flooded forest, where seeds, fruit, insects, and new shelter become available. During falling water, many routes close, and animals concentrate in channels, lakes, and connections between rivers. A dolphin that hunts only by chasing whatever happens to pass its nose would miss the larger pattern. It benefits from occupying places where the river itself brings fish together, separates them, or forces them through narrow passages. The predator is not just searching for prey, it is operating inside a calendar written by water level. Flooded forest can reverse the normal meaning of size. More water gives fish enormous new spaces in which to disperse, and a predator may have to search harder for each encounter. But the forest also creates edges, bottlenecks, trunks, floating vegetation, and shallow passages that constrain movement. The Boto's advantage is not that every obstacle helps it. Some obstacles protect prey. Others give the dolphin a surface against which escape choices become predictable. As water rises and falls, the same location can shift from refuge to trap. Hunting success therefore depends not only on anatomy, but on timing, experience, and the local structure of the floodplain. River junctions can make that calendar even more important. Where two rivers meet, currents carry different temperatures, sediments, dissolved chemicals, and food pathways. Fish may use those boundaries as routes or feeding areas, and recent ecological work has linked dolphin aggregations with places where fish abundance and diversity are higher. That does not mean every confluence is a permanent feeding station or that dolphins gather there to stage attacks. It means the animals may gain an energetic advantage by hunting where hydrology concentrates opportunity. The river does some of the sorting. The dolphin arrives with a sensory system capable of exploiting the result. This is where the simple story of predator versus prey begins to break apart. The boto does not need to be universally faster than a piranha. It needs to find the piranha in the right place, at the right distance, when the fish's escape options are limited by current, roots, vegetation, or the presence of other fish. A piranha shoal may reduce the odds that one fish is targeted in open water, but a group can also become a dense acoustic and visual cluster. If a dolphin enters the boundary at close range, the same concentration that offers protection may provide a larger field of possible captures. Still, piranhas are not passive. They can accelerate, turn sharply, bury themselves near cover, and use group movement to reduce individual exposure. The dolphin does not win every encounter. Diet records are evidence that certain prey were consumed, not a complete record of every hunt that failed. A fish that escapes leaves almost no trace in a stomach or tissue sample. That distinction matters. The title promises fear, but science cannot infer an emotion simply because a fish retreats or forms a shoal. What can be measured is risk. The presence of a predator changes spacing, movement, vigilance, and the routes an animal chooses. Direct observation remains the missing window. Scientists can examine diet remains, record clicks, map habitat use, and measure responses to controlled prey presentations. Those methods establish capability and pattern. They do not provide a complete underwater catalogue of which fish notices a boto first, which cue triggers escape, or how often a piranha successfully turns its teeth on an attacker. Mud protects the drama from cameras as effectively as it hides prey from human eyes. The uncertainty should sharpen the story rather than weaken it. We know enough to overturn the hierarchy, but not enough to narrate every chase as though someone watched it from beginning to end. The boto's apparent blindness is also more complicated than the popular image suggests. It is not literally unable to see. Its eyes are functional, but vision competes with a habitat that disrupts distance and shape. The animal's acoustic system gives it information in the dark and the mud, while its flexible body helps turn that information into movement. One ability without the other would be less useful. Sound can locate a fish, but a rigid body may fail to follow. Flexibility can create a sudden angle, but without close-range echoes, the dolphin may lose the target. The predator's success emerges from cooperation between parts rather than one spectacular feature. That cooperation creates a hidden dependency. The same dolphin that can search flooded forest, track prey through silt, and exploit confluences depends on the forest being connected to the river. It depends on seasonal water levels opening and closing habitats in a familiar rhythm. It depends on fish moving through channels, rather than being removed before the predator reaches them. A dam can alter that rhythm. Fishing can reduce the prey field. Nets can convert a hunting corridor into a lethal barrier. Boat noise and engine traffic can add a layer of disturbance to an animal that relies heavily on sound. The threat is not that the dolphin suddenly becomes less intelligent or less powerful. The problem is that its map stops matching the river. A flooded forest may no longer fill at the same time. A tributary may become inaccessible. A fish community may be reduced or rearranged. An acoustic signal may be masked by machinery or boat traffic. In that altered environment, the boto's specialization becomes a liability. It has evolved to solve the problems of a connected, seasonal system, not an artificial channel in which water, prey, and sound have been rearranged. This is also why the pink predator should not be treated as a mythic apex monster. Its success is conditional. It is powerful in the places where its body, sonar, prey, and river geometry line up. The same animal can be a dominant hunter in a flooded forest and a vulnerable mammal in a fishing net. A piranha can be a dangerous biter near food and a small fish avoiding isolation. A river junction can be a feeding opportunity and a place of intense human traffic. Predator status is not a permanent crown. It is a relationship between anatomy and circumstance. Put the evidence together and the title becomes more precise. Amazon river dolphins do eat fish from the piranha family, and their hunting system is well suited to finding and intercepting prey in dark, cluttered water. Their size gives them force. Their flexible neck and flippers give them control. Their teeth allow them to grip varied prey. Their biosonar supplies a moving map, and their changing click pattern helps them manage the final approach. Seasonal movement and river junctions can place them where fish become concentrated. The piranha's teeth matter, but only after the fish has recognized the threat, faced it, and reached biting distance. The deeper answer is not that every piranha is secretly terrified of every botto. The stronger answer is that the Amazon's most intimidating fish live inside a food web where their famous weapons do not guarantee control. Shoaling can reduce the danger of being singled out, but it cannot erase a predator that can search through mud. Speed can create distance, but it may not matter in a maze where the dolphin turns more effectively. A bite can injure, but it is useless against an attack that begins with the prey being detected and positioned before it understands what is happening. And that changes the meaning of the pink back breaking the surface. It is not a friendly-looking animal hiding a simple appetite for violence. It is the visible edge of a highly specialized river hunter, one whose power comes from reading conditions that humans often experience as blindness. Beneath the surface, the same clicks that once sounded like an invisible threat also reveal a vulnerability. They mark an animal that cannot separate itself from the flow of water, the movement of fish, and the acoustic character of its home. Somewhere below the brown surface, a piranha shoal tightens. The fish are not forming a perfect army, and they are not waiting helplessly for a monster. They are responding to risk in the only world they know, by staying close, moving together, and trying to make any single target difficult to choose. Then a sequence of clicks crosses the water. The dolphin turns, the acoustic field widens, and one fish becomes more than a tooth-filled predator. It becomes a signal in the Boto's map. The Amazon's deadliest fish are not afraid, because the pink predator is magical. They are vulnerable, because in this river, being dangerous is not the same as being unseen.